Hi guys, Dr. Diaz here again. Okay, and now we're going to solve this problem using Kirchhoff law. Kirchhoff rules. We're going to use the junction and loop rule. So this is the problem that we watched in the last video, and I'm going to solve it slightly different from how they did it on the PowerPoint. So look here, I'm not going to use the direction of these currents. The junction I'm going to use is not even this one. I'm going to use this one. So I draw the circuit again. Oh, remember this one here is 4 ohms. This one is 6 ohms. This one was 2 ohms. Okay, and the current and the direction of the current, I'm going to use the one given by the biggest battery. This one is 14 volts versus this one is 10 volts. So this one for me is the one that's going to do the direction. That's actually more or less how I learned it. And here it goes. Since this is the biggest battery, the current goes from here is going to be this one. We're going to call it I1, which is the one that goes through the resistor of 4 ohms. And the current going here, we're going to call it I1. And I1 seems to be going into the junction. And when it goes through this resistor, it will polarize this one from plus to minus. If you remember reading the other section, the other video, the way things are being polarized. Right. Now this one here, this resistor, the 6 ohm, is attached to this battery. So this one's going to be polarized by its own battery. So it's going to be plus minus, that's easy. But this one, the third one that doesn't have a battery attached to it, well, these two, you can share these two. We're going to say that the biggest one is the one that's going to tell the direction, and this one is also going to polarize, because in this case, I3, which is the one I'm going to call this one, is leaving the junction, and when it goes here, we polarize this one plus minus. This one, I forgot to call it, we will call this one I2. And because I2 goes from plus to minus, when it goes here, it will be leaving this junction. It will go here then, but it will be leaving the junction because it's the direction of the current, right? Our current always goes to plus or minus, so it will be in this direction, and we call this one I2. So if we write here the junction again, we have, this is basically what we have. We have I1 going into the junction, I2 leaving the junction, I3 leaving the junction. So if we do here the rule of junction, it's going to be the sum of the current is going to be equal to 0. So according to this, I1 is going in, I2 is going out, I3 is going out. So we put I1 minus I2 minus I3 is equal to 0. Right. Now we're going to do the case 4 of the loops, the rule of loops. We already have the junction here. We got the equation. This is the equation we're going to use to solve the problem. Now let's solve the junction in a second. Well, I should say not junction, but the loops in a second. And what we're going to do is we're going to divide this into 3 different loops or branches. Here's one, and then drawing here the direction of the current, and I'm going to call this one 1. Here's another one. I'm going to call this one 2, and the other one I'm going to call it 3. So it has 3 loops. So in other words, if we look at this circuit here we have in a second, I'm calling that, we're going to call this one I1, the loop 1, this is the loop 2, and the other one is going to be loop 3. It goes in this direction. And later I will tell you why this is important, drawing the direction of the current and the flow of the way we're going to calculate the voltage and give the numbers to this one. So let's do first the loop 1, the first loop. Aha, voila, look, magically, there's the first loop. Remember, what we're going to do here is we're going to solve only this upper part of the circuit. You see, remember this one? We're going to solve only loop 1. We're going to forget that this one is actually even assist for solving loop 1. So we only took the ones, all the devices that are labeled in loop 1, and whatever is not there, which is this one alone, we leave this one alone. So here's our circuit. The first thing we're going to do is use the rule of loops. It basically says that the sum of the potentials is equal to 0. And since the direction we established it going like this, when this loop, this arrow goes here across this battery, it ends up looking at the positive side of the battery, so we call that one 14 volts positive. When it goes through this one, Okay, this arrow end up looking the negative side of this resistor, so this one is gonna be called minus 4I1, because if you remember, the current going to this one is I1. When it goes here, you see here comes the loop, here comes the loop, it ends up looking at the positive side of this battery, what we call it plus 10 volts. And finally, when the loop goes through this one, see, it ends up looking at the negative side of the resistor, so it's going to be minus 6I2. And you can see I dropped the ohms because the rule of loops, it basically works with voltage, and 6 ohms times whatever is a current is going to be volts. So yeah, let's drop those. And actually in a second I'm going to drop this one, because at the end the answer what we're doing here, we're going to solve for I to find the current. Now look, this 14 and this 10, you can regroup this one, and we can, well, 14 plus 10 is going to be 24 volts, minus 4I1 minus 6I2. This gives some space because there should be I3 is equal to 0, and this is the first loop. Now we're going to drop in the second loop. Here we have the second loop. Second loop, and the direction of the loop will go something like this way, counterclockwise. And look, we're going to do exactly the same thing we did a moment ago. The sum of the potentials of the loop is going to be equal to 0. We start from the battery. When the loop goes here across the battery, this is the negative sign, so it's going to be a minus 10 volts. Go here, when it goes through this resistor, it ends up looking the negative side, the loop, right? The direction of the arrow of the loop, end up looking the negative side, so we call it here minus 2I3. We drop the ohms. And when we go for the the next resistor, the 1 to 6 ohms, when it goes the loop here, it ends up looking the positive side of the resistor, so it's going to be plus 6I2 is equal to 0. So let's arrange this one a little bit. Let's put here minus 10. Let's give it space for 1, then plus 6I2 minus 2I3 is equal to 0. And this is the second equation for the second equation for the second loop. Now we had to do the one for the third loop. Now we have here the third loop, but if you remember, there was something here like a battery and another resistor. For the third loop, you take only the components that are outside. The one that was here, something like this, resistor. Okay, we don't use this one. So it's only the elements outside. So you see, every time we discriminate against one of those, like in the previous one, the second loop, we get rid of the upper part, right? The first loop, we work only with these. Only these, and we forget about this one. We forget about this one. The second one, we work with this. That's what we did a moment ago, and we forget about this one and this resistor. And the third one, we go for the ones that are outside. So let's go and solve that one to write the equations of the loop for the one outside. This one. So then we do the same thing. The sum of the potentials is going to be 0. And here we go. We know the direction of the loop goes this way. When the loop goes here, it ends up looking at the positive side of the battery. It's going to be 14 volts. This resistor is going to be minus 4I1. There's no I2, and it goes this one, end up looking at the negative side. It's going to be then, let's put here, minus 2I, and actually this is I3. I'm sorry about that. I3 is equal to 0. Okay, now I'm going to write all three equations here in a second, and we're going to start solve these equations.